Hey guys, welcome back to another episode of Simulators. Let me just drop the camera a little bit, and then we should be good to go. Okay, so, today we're going to be continuing what we were doing yesterday, which is working on our lens visualization. Now here's the thing, we are pretty much done with this simulation. We don't have very much left to do except create a whole bunch of different lenses and fix the whole thing where we have one ray that is moving above and beyond all the other rays, so we have to fix that. As far as an introduction, I'm going to give a brief introduction like I do every day, but of course, if you have any questions, let me know, because I can totally answer those questions as soon as I see them in chat. Okay, so let's go ahead and get started by opening up Zernal and talking about what the system is we're working with. Okay. There is a little bit of confusion here that I do want to clear up, because I've been rather vague as to how this simulation works up until now. So here we have a circle. Perfect circle. I'm one of the best circle drawers imaginable, especially when I have a tool helping me draw the circles. If we send light at this circle, and we assume that the circle is, well, let's say a standard index, well, then we expect the light to move something like this, and then pop out on this side, something like that. It should be, you know, that we see some sort of refraction towards the normal here and away from the normal there. And by normal, I simply mean perpendicular to the surface. Okay, so that's pretty cool. This is what we'd expect. Now, the thing is, with our simulation here, we have a bit of an odd index that depends on R. So here is our R value, here. So this means that we can create crazy functions that are not just standard. They're not just 1.4 or 1.5. Instead, they are maybe 2R, or let's say, I don't know, 1 over R. Or maybe the error function of 1 over R. Or, I don't know, it could be anything, really. And it doesn't really matter what it is. The point is, we have some sort of weird circle that's varying with R. And what a lot of you guys may be thinking at this point is that what we're doing is we're creating a whole bunch of concentric circles. 1 circle, 2 circle, 3 circle, 4 circles, so on and so forth. But that's not quite what we're doing. Instead, what we're doing is we're saying, okay, each ray is essentially a ball that is moving in some direction, right? So it has some sort of velocity and some sort of position. The velocity is equal to c, 3.0 times 10 to the 8th, presumably. The position is going to be equal to the velocity times the time step that we have given it, and the time step's predetermined. So, hey H226, and I care, of course, hey. So, the issue here is that, or what we're actually doing here, is we're calculating how far light moves every single time step, and we're moving it forward based on that. Now, this is a little bit different than the other way around, and honestly, it helps us create a dynamic grid on the inside here, because it could be a situation where we simply have not resolved spatially the grid enough in here. By grid, I mean these concentric circles. It could be that in some cases we, I don't know, we have light coming in, and then as it gets closer and closer to the circle, we need an incredibly small spatial step. And in order to get that incredibly small spatial step, we would need to basically have an incredibly small grid along the entire XY plane. This allows us to have a grid that's not so small, right? A grid that's dependent on the time step, if that makes sense. So this is kind of the idea here. Instead of moving based on some spatial grid, we're moving based on a time-resolved grid. And this helps us out significantly. In fact, it might not even be a grid. We move according to some time-resolved step. And that that is what makes this simulation so interesting, because it allows us to get more at the heart of the dynamics of the problem. Now, it's not quite accurate, because if our time step is too large, it could be a situation where, same as before with the large spatial step, we all of a sudden are thrown off the appropriate course. But it is more accurate than the spatial step for a number of reasons, and for that reason, we will kind of keep it as is. It's also performing exactly what we want it to perform, so there are a few things that we need to fix about the simulation, and I'll admit that, but I'm really happy with how far we've gotten. In fact, this simulation is one of those simulations that it's not something you're going to find in real life. You know, you're not going to find these lenses anywhere anytime soon. But it's super interesting to look at. This is a purely theoretical yet physically intuitive subject to just study, you know? And it's not something that, again, it's not going to make a huge difference in research, but maybe it helps people intuitively understand things a little bit better, and maybe it's just cool. I don't know, but for me, it's super fun. And I'm hoping you guys enjoy watching it as it develops. And of course, if you have any questions, comments, concerns, let me know. I'll totally get to those as soon as I see them in chat. But at this point, guys, that's basically all there is to it. I don't have so much more to introduce. Just wanted to make sure that I had mentioned this at the start of the stream, and now we can go ahead and get started with the actual programming. The first thing we need to fix is the stray ray at the top of the simulation, which has plagued us since the very start of the simulation itself. Well, since we resurrected the simulation from back in the day. And yeah, after that, we'll just keep going. Keep trucking along, adding in new refractive indices, modifying a whole bunch of crazy things, doing one thing after another. We'll just see what happens. I'm hoping that between today and tomorrow, I think we'll have to do one more day, but between today and tomorrow, we'll have a whole bunch of really cool lenses to try out. And because of the new way we have to introduce lenses, which we introduced yesterday, it should be relatively simple and straightforward to switch between the lenses, which is even cooler in another way. So, all that said and done, all that said and done, I think we are pretty close to being done with this simulation. Now, the question is, where do we go next? And that has unfortunately not been quite solved yet. On the one hand, I'm learning some machine learning on the side. On the other hand, I'm also learning conformal mapping on the side. On the other hand, I'm learning a whole bunch of other things on the side, but I just don't know where to go from here. We could try, since we have a finite difference time domain code that works in 3 dimensions, we could try something really interesting, which is untangling vortex knots, which I saw recently on a paper on the archive. It's really cool. They use what's known as the Fitzhugh-Nagamo something Gerald? I don't know. Anyway, it is a particular equation that is used actually for the potential in your heart, like the potential along the membrane somewhere in your heart. Not sure exactly, but it's an incredibly cool equation, and they use that as if it were a superfluid system, and they can actually untangle knots with it, vortex knots. So it's a way to untie a knot with just a basic FDTD simulation. Really cool. I want to try it, but I'm afraid it's going to fail miserably if we try it on this channel, like everything else I try. So we'll see how far that goes. Anyway, guys, at this point in time, we are good to go. So I'm going to go ahead and get started, and we can just see how far we get. So, of course, let me cd into the appropriate directories: projects, Simuleos, Geometrical Optics, and of course over here, cd projects, Simuleos, and Geometrical Optics. Good, we're where we need to be. Let me just go over here and let me run the make command real quick just to see what we have. I'm pretty sure this is it's a sweep, just to make sure the simulation was working. Now in this sweep, we have a refractive index of exactly 1. So after you see the sweep, you're going to see that it's basically going through the lens. Hey Gustorn, what's up? So let's take a look at that just to make sure we have everything. So run the last mirage. Move over here. Good, let's zoom down. Oh wait. Oh, it's an index sweep, of course, never mind. We're changing the index dynamically as we go through, which is about what we'd expect. Now, one thing about this, did I already fix the one stray ray problem? Oh, kind of. But I don't like the solution that I put in. Yeah, let me go over here. Let me try something. So what I'm going to do is I'm going to go into geometrical.cpp. Now we have a bit of a problem with a couple of different systems. So let me try something real quick. Instead of propagate mod, let me just try propagate. Here. And what do I want to do? I want the refractive index of the lens to be actually 1.4. Okay, now let me make that. It shouldn't take as long to make, I don't think. Yeah, it shouldn't take as long at all. And then we'll see where it goes from here. So let's do Mirage Temp, scroll down. Okay, there we go. So now we have a single ray being drawn along here. And my question is, well, first of all, why it's not refracting. Should be refracting. Oh, oops. This is not 1.4. We need to fix it. Where is it? Lens P. Here it is. 1.4. Okay, let me try this one more time. And actually, let me go down and change where this ray is being drawn. So where's propagate? Propagate is right here. And we say the first ray... Oh, no, light gen is what I need. We say the first ray, let me see, is being drawn at 0, 0. 0 in X, 0 in Y. But I actually want to set this down to something else, which let's say is 25 in Y. Now let's make that. And I think this will do what I want it to do. Yes, the max index is 1.4. So we should see light coming in, being refracted, and we should see a single ray on top. Okay, so do we want to keep this ray on top? That's the question. On the one hand, I kind of like it there, because it shows you how much faster light is when it doesn't go through the lens. And I kind of like that. On the other hand, I've got a feeling that, you know, it might look better without that ray. You think it's good, Gastron? Yeah. Well, let's see what happens. So here's what I want to do. Oh yeah, I could draw it with a different color. Let me see. Okay. So let's go through first. Oh yeah, you guys want a chromatic dispersion. We might have to get that one tomorrow. So let's see. Here's previous index. Seems fine. What I want to do then is, let me see, raise offset. Are we reading an offset? How do we define offset? Okay, good. So if you guys are happy with that ray, then we can keep it in there. But let me change how we're doing offset. So where's offset? Offset is being read in. And let me just define this as offset divided by 2. .0, why not? Write this, go over here, make that. And then we'll see what that one does. It should bring the ray a little bit closer. Sorry about that, guys. Okay, so let's do Mirage. Scroll down. Good. Okay, so now let's see what happens if we run the sweep. Propagate sweep. Yeah, we'll see. Yes, you did, Edge. It was actually really cool. Let me see. So, constant index. What do I want to do? I want to change this to a 1.0. Then I want to go propagate mod instead of propagate standard. Right. This. Go over here, make that. Now, let me make sure the ray is in the picture, because I've got a feeling, because of the way I'm doing the, I guess the drawing or the writing of the index, I think it might be off. And Edge, if you want to link it again, feel free to do so. I have no problem with people, I guess, advertising their own stuff, especially if it's cool stuff they did on their own that has something to do with programming, you know? In fact, I think that's, this channel's chat is perfectly for that. You wired up a quarter-sized proto board to make the project permanent and not on a breadboard. Oh, wow, really? I'd love to see that. I've never actually used a proto board before, so that's interesting. Let me go here. Let me scroll down. Okay, yeah, this looks pretty good then. I'm okay with that. However, I think it's kind of weird for the propagate mod function. In a way, I think it's kind of weird because this line isn't really doing that much. So here we go down here. Let me see. But then again, it's not that big of a deal. Okay. Open link. Oh, what happened there? I see. Scroll down. I see. Some pictures are blurry due to the webcam. Others are clear due to me taking with the phone. So the phone, obviously, I guess the phone is better than the webcam. Yeah, that's pretty dang cool. So let me see. Back here, yeah, I guess it does exactly what you'd expect, but it didn't have access to the phone for all of it. Yeah, fair enough. still, I think it's really cool when people work on their own kind of side projects. And I don't know. See, for me, I kind of enjoy just making things, you know? And I find it fun to watch other people make things, just because I find it fun. Now let me scroll down a little bit, and let's see what happens here. Okay. That's fair enough. I don't think the soldering takes so long. I think it's just a matter of getting through all of the elements, right? I've done something similar before, but it's been a while. Okay, so let's take a look at this as it's going through. Should we keep that ray up there for the propagate mod function? I don't know. Maybe, maybe not. I don't think it does any harm. You know, it's clearly different than the rest of the ray, the rest of the rays, right? So maybe it's okay. Yeah, maybe it's okay. We'll see what happens. Yeah, the first time I had to solder something, it was... Oh my gosh, I can't believe I did this. Here's what happened. So my friend had this laptop that was not working. And I thought to myself, I can fix this laptop. So by not working, I mean the power button would not, in any way, the power button would just not turn on the computer. So I knew it had to be a problem with the, how do I put this? I knew it had to be a problem with the wire that was connecting the power button to the rest of the motherboard. So I said, okay, well this is totally fixable. I took the power cord, I stripped it, I soldered a whole bunch of wires to it and wires to the appropriate connections on the other side, and then it worked again. I got the computer to work, and I was so happy with that. You know, I'd never seen it done before like that, and I just thought it was neat. I was so happy at the end. So let me go down then to the propagate mod function, and let me see what we got here. I think I will remove the ray because Gusprint says it's a good idea. Okay, so the vector position here is going to be, let's see, vector 0, 0, I times 2 times lens radius divided by num frames minus 50. Alright, see you in a bit, Edge. So, what do we have here? This, I think, should be okay. I think the sweep ray should be okay. We'll take a look at that in a second. What I want is the propagate mod function. Here it is. So in this case, we've already done the light gen, right? So what we should probably do, I animation current frame, we have propagate, raise, lens, step size, max velocity, animation, 0. Okay? So, what do we need to do here? What we need to do, let me think. We need to modify the rays in propagate mod so we don't have that one ray. Now we can actually do this a number of ways. Let me go into light gen. Yeah. And I agree with you, Gustorn. Okay, so let me go up here to light gen. Here we are. And we have constant lens T, double max velocity, and double angle. Okay. So what I want to do then, let's see, constant T lens, double max velocity, vector dimension. Do we use dimension? Yeah, I guess we do. Okay, so let me add an additional flag in here, which says, Boolean, and it's just super simple flag, mod. Can you put the top right index 0 or length -1? Then you just skip it. Can you put the top ray to either index 0 or index length -1? The top ray is already at index 0. However, because of the way I'm currently doing the propagate mod function, it calls on propagate. And because it calls on propagate, propagate starts with I equals 0. So I either have to read a flag in here to have it start at I equal 1, or go down to the bottom, or modify the rays that I'm reading in. I think. I can't think of another way to do it. So I kind of have to make a choice, right? I have to either modify the rays the rays array, or I need to modify this statement in here. I guess it's not so bad. Let me think. Double time, rays, constant T lens. Double time. I have propagate up right here. This is the appropriate stuff. So here's propagate. And we're reading it in, propagate mod. Yep, sure. Not a problem. Let me go down. Propagate sweep. Propagate mod. Okay. So we have ray, rays, T lens, double step size, max velocity, animation, double index max. We have lens.index parameter as 0.0. And then we just say for I start frame less than number of frames. We basically do propagate for each of the different index parameters. Now let me see, what is this down here? For an I equals animation current frame. I less than number of frames, I plus plus. Oh, okay. Let me very quickly go down here and write setting the final image to the rest of the animation. Good. There we go. Yeah, that's exactly what we're doing. So let me go down here, remove this line. Yeah, so I'm thinking the best way is to modify the rays, just because I think that's a little bit cleaner than modifying propagate. But in the end, it doesn't really matter that much, right? So C++ way of doing this would do something passing begin iterator instead of the rays vector. Well, we'd have to send the vector in, right? So I don't see any way. Does the iterator carry the vector too? I've never actually done that before. Oopsie, that was a mistake. Accidentally pasted. Clear. I've never done it that way before. We could try it. I don't see any reason why not. So what you're saying is we have an iterator, but does the iterator naturally carry the vector? That's the question I have. I don't know. I don't use iterators that often, actually, because usually you can just do some sort of index. Propagate begin rays, end rays. I mean, it seems to me easier just to go into propagate, or light generation. Where are we? We are, let me see. Let me see, end in propagate mod you would call begin +1, end. Okay, so we can actually solve this problem in a really cheatsy way. Like really, really cheatsy way. If I set this here, this offset. Yeah, that's fair enough, thank you. So if what I want to do you want to see the easiest way to solve this problem is to set this vector to be at position 0, 0. If we run make command here, the ray is not going to be visible in the propagate mod function. However, it will be visible in the propagate in the standard propagate function. So here's propagate mod. Let's take a look at the images. Obviously the ray is not present. No additional ray up here. Then if we run propagate, one second, let me go to propagate. Where is it? Here. One second. And make that, it'll be there. But we kind of cheated, right? And I feel kind of bad for doing that. The reason it doesn't appear in the other one, Mirage, let's scroll down. So here we have the ray all the way up there. And the reason it doesn't appear in the other one is because we have a, how do I put it? We have a box that's currently covering this entire area up here to draw the index to. So we kind of cheated. Add a comment and we're cool. No, I kind of want to do this correctly. So let me go down to the propagate mod function again. Let's go here. And where are we? Light generation here. So let me just go ahead and add in a quick flag, which is the mod flag. Okay, flag is not a, let's do Boolean. But it also I feel like this ray up here is also kind of too high, you know? So it kind of, this solution is actually better. Why is this solution better? I see no reason why this solution would be better. Hey, Mr. Sutherland, what's up? How have you been? I think it's just a hack. I don't like this idea. Because, I don't know. It just strikes me as weird. Because all we have to do down here is say, okay, well, the y position is going to be offset divided by 2, like it was before. Because you don't have to change two things when you change between propagate and propagate mod. Let me think. Oh, oops. Those are question marks, not dashes. Oops. Okay, there we go. Let me think. Because you don't have to change two things when you change between propagate and propagate mod. What are we reading into? Good, just took an Intro to C course the other day and learned that zero array achieves the same as array 0. Oh, I actually didn't know that. Thanks for commenting. So let's see, what do we have? Propagate here. Let me see, where am I drawing? I think it's in propagate mod. So let's see. Propagate sweep. Then we have the iterator thing would solve it as well if you want a non-hacky solution. The Boolean flag totally sits it. What do you mean? The iterator thing is the hacky solution here. The Boolean flag thing is not the hacky solution. The Boolean thing makes a lot of sense, you know? This one makes intuitive sense. The iterator thing is like, we'll just use some hacky C++ thing, you know? Like, it's not, because then every time we read in propagate, we don't read in, yeah, we'd have to modify how we're reading in raise. Let me see. I don't know, I mean, alternatively, we could just do this, and we could just say, okay, well, let's go here. We go down to propagate mod. And then we just remove the first index from down here, and we say we create a new array of light rays. But I don't like that solution because it wastes time. Meanwhile, the other one wouldn't. So I would think the flag thing to me seems like a more standard approach. Like it seems, it's super, it makes a lot of sense. The iterator solution makes it more generic because you're not limited to using ray array anymore. What? You have to use ray array. I'm super confused. So you said if we do the iterator, you have begin rays and end rays. I don't know what that, I'm a little bit confused. Well, yeah, I like it because it's hacky. I don't think it's great because this ray is so far above the circle, right? I just don't think it looks good, you know? And we can increase the text box size. Let me see. So we can increase the text box size by changing the print index function. Let me go down there. Here it is there. And there it is down there. And we can just increase this to be a much larger size. So it could be, let's see, we're reading an index, we're reading color. You know, we could set it up to be like 100 or something like that. In that case, we would we definitely cover any of the lines. But okay. I don't know. I think modifying the rays, I think that's the cleanest solution. It's in my opinion cleaner than the iterator stuff, which is kind of messy and hard to read. So at least the way I'm thinking about it. Besides which, it doesn't make sense because we're only removing one ray, right? I guess I'm just, anyway, it's fine. So again, if you guys have any questions, let me know. Let me think. How we want to approach this? So dd. Let me write this. Okay, let me try running this again one more time. Let me see. We have offset. I misspelled offset. Let's go here, offset. And let me go up here and change the index to 1.4 instead of 1. Let's change it. Yeah, 1.4 is okay. Write this, go over here, and let's go ahead and make that. It should work, no problem. Oh, we're doing propagate sweep, propagate mod, aren't we? Yep, totally are. Let's change that. Propagate. Write this, go here, Control C, make. That was make. Okay, give this guy a second to run. It literally takes no time at all. Well, not literally. It takes a little bit of time. It figuratively takes no time at all. That's what I should have said. My apologies, guys. Mirage image. Okay, so here we have the ray going through. Yeah, I think that looks pretty good. Okay, now let's see what happens if we have it going through at another... Yeah, or we could do it this way. Let me see. So this ray also looks a little bit thicker for some reason, but can't be. No, it's not. Okay. Let me scroll down. We have print index here. And again, again, I just don't like this solution because it's super hacky, but we can change this to be like 100 or something. Let's go over here and let's make that. And then this should remove the top line, but not anything else. I think it's actually going to remove part of the, let's see, Mirage. Oh, it's not propagate. 1 second. I'll take a look in just a second, Gastorn. Let me go down to propagate mod. Make. Let me see. Open link. Okay, let me see what we got. Void propagate, I begin, I end. Oh, you want me to use a template. Auto ray equals begin. Man, templates to me are still super hacky. Like, they just... I don't know. Let's see, void propagate, I begin, I end. For... I don't know. It's fine. I just... propagate sweep actually doesn't use a ray array, so we wouldn't need it for propagate sweep. But... Let's pop over here real quick. Let's take a look. Yeah, it covered some of the circle. Alright, let me go down here. G. Let me set this back to... where's print in? Oh, here it is. 20, where it was before. Write this. Go over here. Let me think. So what you're saying is we have template name I guess for iterator, then void propagate I begin, I end, for, and how do we call it down here? SD begin raise, SD end raise, propagate, let me see, for begin not equal to end, plus plus begin, auto ray is equal to begin. Okay, I mean, we can do that. I need to get better with templates anyway. I just don't like it because we're only removing one element, you know? Like, if there were a whole bunch of rays that we were showing, this would be maybe a little bit different. Okay, that's fine. Why not? So, let's go here. Close this. Clear this terminal. And let's go up here. Yeah, I don't like the solution where we're just covering up the ray by a box. It just seems weird, you know? Like, so let me see. We go to light gen, and we generate an offset divided by 2. That seems fine to me. Okay, so what we need to do then, propagate is already a template. So what we need to do is change this to template T I. Yeah. I'm not really sure what I need to do here. Real quick, let me think. So, can we do a template with more than one variable? That's the question, and I think you can. Type name IT. You type name before the second I. Okay, let's do that then. Type name. Okay, and then we do the following. Let me see. So it's going to be, what was it? It was I begin, I end. I end. Okay. I think it's only propagate we need to update. So let me go over here. Let me go into vi geometrical.h. Let's go down to propagate. Here. Let's see. We want to change this to type name t, type name I. Go down here, and let's do I begin, I end. Okay. So now we have those guys. And let me think. So now we have to update all the propagate functions. We go up to the top. Oh, that was not the top. That's what I want. But propagate sweep doesn't even call the ray array. You do it for propagate mod too. I mean, I don't know. I kind of want to leave it out of propagate mod for now, just to make sure it works, and then we'll go from there. Because I had a heck of a lot of trouble with these templates yesterday, so I've got a feeling I'm gonna have a heck of a lot of trouble today. So let's see. We have propagate I begin, and what you're saying is what we need to do. Propagate here. So let's go here and let's change this to. What do I want it to be? I want it to be. You say std begin raise, std end raise. So let's do std begin raise and std and raise. Okay, now let's go here. But I do agree with you for consistency. So let's just make sure this works, and then let's go down. Oh yeah, you're right. Sorry about that. Propagate. Here, and of course it's down here. And we say for size t I equals 0, I less than raise.size plus I. But what we need to do is for... Wait, are we allowed to do that weird semicolon thing you did? I'd never done that before. So we'll say... Let me think. We say begin not equal to end. Not equal to end. Plus begin. Was that right? Let me see. Void propagate. Propagate begin +1 end. Wait 1 second. Begin not equal to end plus begin. Auto array. Oops, sorry about that. It's going to be equal to. Huh. I didn't know that. Pretty interesting. So let's do auto array is going to be equal to. I guess it's just going to be. Just begin. I guess. Yeah, begin. I guess that makes a little bit of sense. Okay, so let's go here. Let me write this. Okay, now let me go down to propagate mod and let's modify that function. So where is propagate mod? Let me go down. Let me see. Propagate mod is right here. So we're going to say every time we do propagate, we want to do following. We want to say std begin raise and std end raise. Let me see. Or if you want to be really expressive, int equals 1. Okay, so let's see what we got here. Let's go ahead and pop this down to the next line. I don't remember where I popped it down last time, something like that. Let's go here, write and quit, make that, and see where it breaks. Okay, so this one seems to be running okay. Now let's see what happens at the end. Okay. Geometric, ooh, that was not what I meant to do. Let's do the last mirage. Okay, so that one seems to be okay. Now let's do propagate sweep. So let's go up to main. Here we are. Propagate mod right here. Remove propagate sweep, or propagate, sorry. Go down here, make that. And let's see what happens. Propagate raise. Where are we? 320. Oh, I know what I did wrong. Sorry about that. We have to add these here, and actually, let me see. We want to do std begin, std end. Yeah, you're right. Bring step size down to the next line. Okay, And we want to do +1 here for begin. And down here, +1. Let's make that. Good, so it seems to be running okay. Now let's see what happens at the very end. Do I have an index? I think I have an index of 1.4 or something. Give it a second to run. And then we'll take a look. Okay, so now we need to mirage, scroll down. There we go. So it is without the line. Good, exactly what we wanted. So what do I want to do next? Let me see. Gusterman's over there saying, somebody needs to propagate 2. Yeah, you can write an infinite loop like this. If you want to be really expressive, int equals 1 for... Oh, I see. Let's see. Let's test it first. Wait, sorry, I'm doing what? I feel like I missed something. Okay, so the last thing I need to do, or the next thing I need to do, is check out propagate sweep. So let me see, propagate sweep right there. Could propagate mod. Comment that out. Propagate sweep here, right here, and let's make that. Okay, give it a second. Light array raise. Yeah, obviously it's not created in propagate sweep, or not necessary in propagate sweep. Okay, now let's do the last mirage. Scroll down. Okay, so the very first one, the very first character is already not, so it's set exactly where we want it to be. This is pretty good. Yeah, okay, so all of them are refracting, so we don't have to worry about changing propagate sweep. I think this one's already set. Good, okay, that looks pretty good. Good, okay, so let's go ahead and close this. Now, what do we want to do next? Next, we want to add in a whole bunch of weird lenses, and I'm trying to think of the best way to visualize this, and I'm not quite sure. So we can do it in a number of ways. What I might want to do, we have propagate sweep, we have propagate standard, propagate mod, and then we do propagate with a whole bunch of rays, right? So what I might want to do is I might want to do propagate sweep first, so we see a ray of light moving through the lens. Then I want to do propagate, which allows all the light to just move through the lens, and we see it moving through the lens. Then after propagate, I might want to do propagate mod, since we start with 10 rays in both cases, or 20 rays, and we see the light being kind of moved in and out, like as the index changes. And then what else might I want to try? No, what I need to do is, yeah, that's kind of complicated. What I could also do is just put all of the simulations on the screen at once. I don't know, that's just an editing problem. I guess right now we should worry about getting the videos all done. Now for propagate mod, let me think, std begin rays, std end rays, should we add that into propagate mod? We could, but I'm actually fine with how it's running right now. I mean, it makes a good bit of sense to me right now. Let me see. So we do propagate mod down there. Sorry, propagate mod. Here. Yeah, it's not easy to fix that one, actually. Let me see. For start frame, number of frames. Yeah, because we just read the ray array. Rays? Because we just read the ray array into propagate, the propagate function. It's kind of not necessary, I think, to update propagate mod. I think I'm happy with how that one's running. Okay, so now let's go ahead and add some lenses in here. We've got a lot of lenses to try, and honestly, guys, there's one particular lens that I still cannot figure out. You could just add a propagate to take an array and immediately forward it to the iterator version if you wanted consistency. Add a propagate to take an array and immediately forward it to the iterator version if you wanted consistency. Yeah, we could. It could just be some sort of overloaded function that, yeah, we could do that. Let me think. Yeah, I mean, but at this point, I think it's fine, right? I mean, all the different propagate functions, right? So, truth be told, right, I'm kind of gonna plead the whole, like, people are not gonna really be using this code type of thing, you know? It's just me and a few other people who might be interested who will be using the code, right? So I'm gonna kind of say that it's fine for now. We can update it a little bit later if we want, or if it seems necessary at the time. Okay, so what's next? Let's go ahead and clear this terminal. Now, what do we need to do? We need to add in a whole bunch of different lenses, and we need to test them out one by one. So the first one I'm going to test out is the inverse error function one, or error function of the inverse. I don't know what to call that one. So let's go over here and let's go into vi geometrical.h, and let me see, we should have a constant index. Yeah, here we are, struct constant index. So let's go down here, and we're going to say struct for, let's say, error function of 1 over r. Oops, that was a dot. Over r. Good. So, Gusron's already written one of these. So let's just check his to make sure that we're not doing something kind of silly here. Scroll down to the bottom, cs.cpp. And of course, if you want access to this, I can just give you a link to it in chat. Not a big deal. Oh, that was not what I meant to do. I meant to do this. Here. Good. Okay, so let's scroll down a little bit. We have inverse error function index right here. So it's kind of similar to what we had before. Let me see. Oh, crap. 1 second. Right and quit. Go over here. Right and quit. Geometrical.h over here. And now we're good to go. Okay, so let's drop down. Invisible index, inverse error function index. The difference here is that we have a bit of a different formula. So let me go down again to constant index. Okay, now let's pop down here. I'm going to say we have a struct for the inverse error function, which I don't remember what he called it, but it's fine to keep the notation. Inverse error function index. Okay. So what we'll say is the following. Double operator. There we go, got that one. Then we say sphere of inverse error function index ampersand, then we need vector p. Yeah, vector p. Okay, then we say constant. 1 second. This has to have a lens on the end of it. Then we say, over here, constant here, and we go down here and we say double r is going to be equal to distance of lens.origin and p, two things we're reading in, and then we're going to say return error function of 1.0 divided by r. Okay, sounds good to me. Let's go ahead and write this. Now let's see if we can implement this. So it's the inverse error function index. Let's do geometrical.cpp. And as we go down here, we should have a constant index. And what I'm going to say is we go down here and we say constant, inverse error function index. It's going to be equal to inverse ERF or something like that. And we're going to go down here, and when we make the sphere, we're going to read an inverse ERF here. ERF. Write this, go over here, pop that over there, and let's just write that. Now, let's go ahead and make it. Okay, so this gave us a bit of a problem, but it's because I misspelled a whole bunch of things. So let me go into geometrical.h. .h, and let's see, the first one's at 122. I missed a const with a t. Good. Let's see, expected a semicolon, geometrical.h 126. Yep, of course he did, because it's a struct. In main, expected unqualified ID before. Okay, let's go ahead and write this, see what happens if we make it. Okay, so let's go to 54 and geometrical.cpp. vi, ooh, that was a vui, geometrical.cpp. Now we're going to go down and say 54 here, and it says inverse. Let me think. What did I do wrong here? Inverse error function was not declared in the scope. Let me see. Inverse error function index. That's what I've got. Did I call it wrong? No, it seems to be called okay. Let me see then. Inverse error function index, inverse error function. It says expected unqualified ID. However, I'm not really sure why. So maybe I misspelled something. Let me go into geometrical.h. You don't have to declare an extra variable. Oh, you might be right. What? Oh, vi geometrical.h. Okay, let me go down to inverse error function. Let me see. Oh, you're right. I'm sorry about that. Let me see. Where are we going? Inverse error function. Yeah, there had to be the equal 1.4 above. That was me being an idiot. Thanks. Right, quit. Let's make that. Okay, no match call for constant index error function, constant sphere index error function vector p. Return function this, index parameter. Okay. Now let me see. What needs to be done here? Double inverse error function operator, sphere inverse, conversion from argument 1 would be ill-formed. Okay. Geometrical.h. Let's go over here. 96. Return index function. Let me see. Refractive index at index parameter index function. Let me see. We're reading in the index function. Let me take a look at that error one more time. Lens needs to be constant. Auto lens. Let me check it. Geometrical.h. Let's go down to inverse error function. Okay. So we got here inverse error function, struct constant index. It looks to me double operator sphere index. 1 second. Oh, I see. Thank you. Let's grab a const. There. Now let's make that. Okay, so we have variable constant set not used. That's fine. This is something we can edit in a bit. We should be using propagate sweep right now, I think. Let me go ahead and take a look at the last mirage. Wherever that one is. There it is. Okay, and nothing's happening. Yeah, that's clearly nothing. Okay, let's see what happens. What I want to do... Oh, it has to be... Oh, shoot. We have to do something else here. We have to do... Is this... And then we want to divide that by radius. Divided by lens.radius. Okay. Not that this fixes the problem, but let's see. So now we have to go into geometrical.cpp. And let me see, what are we actually running here? We are not running any of the propagates. That would explain why. So let's just do propagate first one. Right here, let's make that. Error, expected I see. Right, let's go over here and let's make that. Good, okay, so it seems to be running. By the way, guys, I did go through and I watched an episode of Simuleos yesterday, and I realized, yeah, you guys watch episodes of Simuleos every day, but, you know, there's a weird thing. I don't know if you guys know about it, but, like, if you listen to yourself talk, it sounds, I don't know, it sounds weird, right? Like, I don't know, it's not something that, honestly, I can stand very easily, but, it is definitely something that needed to be done, so I could kind of check to see what needs to be done with the stream itself. Let's do propagate mod, make that. It was just something I felt I needed to do. And I watched the stream, and I actually, and this is going to sound really, I guess, narcissistic in a way, but I actually really liked the stream. I thought it was really good. Some things, yeah, I think it's because when I speak, I guess the pitch of my voice is a little bit lower than what I think everyone else hears. But that's okay, you know? I watched the stream, and I realized, you know, my voice put aside, I actually enjoyed the stream a good bit. Now, there were a couple things I wanted to fix. The music was a little bit too loud, so I dropped it just a little bit, and I can drop it more if you guys think it's necessary. The other thing I did is I realized I say the word a lot, and I'm trying to stop that, but it's really difficult. Because at some point, especially when it's so early in the morning for me, it's just not easy for me to speak clearly. You know, it's not easy. Okay, So let's take a look at this guy at the end, and we'll see how long it takes. Or we'll see what happens. I think this should give the same plot that we had before. And at this point, guys, we're not going to check to see how physical this thing is, but it is kind of weird to me. I still don't fully... I don't like it. There's something weird about the simulation that I just can't quite put my finger on, if this is the right one. So give it a second to draw all the images. One other thing to note, and I don't know if this is a Cairo thing or not, but every time we draw a new frame, rather, every time we do the simulation again for Propagate Mod, it takes longer and longer. However, the simulation for Propagate Mod is actually easier and easier the higher the index goes. Because, let me run the last Mirage, let's scroll down. Yeah, so this isn't quite what I was expecting to see. No, this isn't quite it at all, actually. So what was I doing differently last time? The Goyim, no? Okay, so this isn't quite what I was expecting. Yeah, no, that's not quite right at all. So let me see. What was I doing before then? Let me see. I should still have it. Oh, no, I deleted it because it was on GitHub. Wow. Okay, I'll take a look at it in a second. That was not what I was expecting to see. So let me go over here to geometrical.h. Let's go down to inverse error function. Right here. I was expecting to see a fundamentally different visualization. So let me see. Distance origin p divided by lens.radius. Seems fine. Let me see. Instead of returning error function here... Oh, I see the problem. That's totally the problem. Okay, so let me see. We're reading in the lens. So let's change this. Actually, inverse error function here. Instead of 1.0, let's change this to lens.index parameter. Since we are reading in the lens. Let's write this. Now, let me go up here. And let's modify a couple of different things. So, constant index I equals index. Should be okay. And what do we have here? So we're doing is we're multiplying by the index parameter here, but I actually kind of want to change how we're doing this. So double index, constant index, double I, index I. Let me see. How are we doing this? So we're defining the index in constant index. And that's fine. So let me think. Let's not multiply by index parameter for now. Oh, sorry about that. And let's just do this. Right, quit. And now let's do make. This finally makes sense to me. There was something weird going on with this simulation before, but I think this should solve it. So let me see what happens. Okay. Because I just realized what we were sweeping through, guys. And now it kind of makes a little bit more sense to me in a way. Visualization that's running now is bugging me out. I'm OCD. But that big extra line goes from end to end. Yeah, so... Oh, the one on my left. I'm sorry about that, Gothic Death Eater. We just kind of changed it a little bit. And I'll show you how we changed it in a bit. We basically took that top line and we moved it up a little bit. The top line still provides very valuable information. The information it provides is how fast the speed of light is moving in a typical case, right? And so it's showing that on the inside of the lens, in this case, the light's actually moving faster. And that's something super important, in my opinion. So, okay. And guys, I'm totally now understanding what was happening with that error function simulation. So, let's take a look here. Geometrical.h, no, I want to do Mirage. Let's scroll down. Okay, this is what I wanted to see. Do you remember this simulation, guys? Okay, as we scroll down, we eventually see more and more rays come in. The speed of light in a vacuum is a constant. You're totally right. It's 3.0 times 10 to the 8th meters per second. However, inside the lens, it's not, because the lens changes in refractive index. So Zadison, you say to add another one. Here's what we actually just did this. So let me do, instead of propagate mod, let me do, let me see. Propagate, no. Let me just do propagate standard. So here's propagate. Let me do propagate standard. And we'll see if this fixes your OCD. So let me make that. Give it a second to do its making. Max index is 1, so this visualization is going to be kind of weird, but that's okay. So now let's go through and let's do Mirage Temp. Let me scroll down. Okay, so now the line is up here. Is that okay? That the line is up here? If not, we can add another line at the bottom, I guess. And that's fine too. It's not so big of a deal, I don't think. But just let me know. Because the line... How does refraction cause resistance against a massless particle? It's not... How do I put this? It's not exactly resistance, right? Let me think. I used to have a good answer to this, but I don't really have an answer to it anymore. Let me think. It's like... You have a type of scattering that happens based on the density of the system itself, right? So, you could imagine that a more dense object has higher scattering of some sort. But, again, I'm not confident anymore in that answer. So I need to kind of look into it a little bit. Sorry about that. For some reason, I'm drawing a blank on that answer. But, yeah, so is this line up here okay with you guys? Like, anything wrong with that one? So, here, let me show you again. Here we have the visualization of light coming in. Something like this. So to get the exact same, let me see, visualization that we have on the left, let me change the constant index here to, no, that should be 1.4. Let me do auto lens radius. What do I want here? I want to do draw lens layer 1 index raise auto lens. I want to go here. I want to say lens dot index parameter is going to be equal to 0.5, and that should solve it. Let's go over here and let's make that. 1 second. No, I didn't watch it. What experiment are you talking about? Mirage Temp? Okay, so does this look okay with you guys? The single ray going along the top? Again, I think it's valuable information, so I feel like we need it in there. So here's the same simulation with the ray going along the top. Let me know what you guys are thinking. Gravitational time dilation? Let me think. Gravitational time dilation. What does that even mean? I'm not sure. Okay, so what are you guys thinking? Is this line okay or is it not okay? If it's not okay, let me know. Oh, the quantum eraser effect. Yeah, I love that experiment. It's a pretty standard experiment. Well, it's one that you see a lot, done a lot. For those who don't know, the quantum eraser effect, let me think if I can get this one correct. The idea is that light or all quantum things, all quantum, I guess you could say particles, are both particles and waves. So quantum objects, I suppose. Yeah. So then the idea. Oh yeah, actually you're right. Light is the same in every reference frame, so that wouldn't affect anything. Anyway, what was I gonna say? So the quantum eraser effect is actually really cool. So the idea is that if you measure a wave function, it collapses into the state you measure it to be. And so the idea then is if you create an entangled state where one wave function is dependent on another wave function, and you measure one wave function, then the other wave function, which again is dependent on the wave function you just measured, is going to be changed. It too will change. Because now you've measured one object, so the other object has to then be dependent on the object before. And so the quantum eraser effect basically says, okay, you could imagine that we measure one object after measuring the expected outcome of another object. And it kind of erases the quantum nature of things, right? Just by adding a time delay between the measurement of the two objects. It's actually a lot cooler than that, but I'm not willing to go so much more into detail because I know people at OIST who watch this stream apparently, and they're going to listen to this and they're going to be like, well, that was wrong. But yeah, it's an interesting effect that definitely is worth looking into. Okay, you guys haven't said anything about the top line. I personally like the top line. Again, it provides valuable information for the simulation, in my opinion. Incredibly valuable information. So I think it's necessary to have in there. But I need your guys' opinion. I need your guys' opinion on this. And since you guys have not said anything about it, I'm going to assume it's fine. So again, that's what it looks like with the line up top. It's a little bit offset, so everyone knows it's okay. And with the other functions that are not propagate, so we don't see light going through. So for example, in propagate mod, it is no longer there. So if we go down to propagate mod, it is gone. Let's make that. Let's link people up with the lecture. Yeah, I have not seen the lecture, so feel free to send a link if you have it. Again, no problem putting that kind of stuff up on chat. The only type of stuff I don't like on chat is if people just pop in for 2 seconds. I've never seen them before, and then they just link their stuff and they leave. Those are the only type of people I don't appreciate putting links into the chat. Or people who put obviously spam in the chat. That's another thing I don't appreciate. But everyone else, perfectly fine to put links in chat. In fact, I encourage it. I encourage you guys to put new information that people can learn from in chat. I mean, that's part of the reason we have a community like this, so people can learn things together. In my opinion, of course. So, I'm pretty excited with this. Let's keep working on the next one, which will be the invisible lens, and then we can figure out how to modify things from here. Now, one thing that is a little weird. What I think I need to do. Do you like money? Check out my site. I hate. Fair enough. Yeah, that kind of thing is the thing I don't like. But everything else, of course, is fine. And we don't get too many people like that on stream. So now for this simulation, guys, the ray is no longer there, as you can clearly see. So that's kind of the thing. I just wanted to kind of point that out your way. That's what we've got. And guys, now let me show you why this is doing something so weird. So first of all, this is absolutely bizarre. But now let me plot for you guys something that is super interesting. So let me just go over here. I'm just going to do it on Wolfram Alpha. Okay, this is so cool. I'm now totally understanding what was happening before in the simulation. Before it boggled my mind, now I get it. So if we plot the error function of 1 over r, we get something a little bit weird. We get something that looks like this, right? Okay, which means we have at the very start, here, let me enlarge. I have to go pro to enlarge. Well, let me just do this then. Okay. So we have a function that looks like this, right? So this goes to about, I don't know, like 0.5 or something like that. So it's like a constant at the center of the lens, and then it tapers off, right? So here's where it tapers off to. So we see some weird effects going on there. Okay? Now, if we multiply this obviously by another factor, let's say 10 over r, then we go down there, give it a second to compute. It'll plot these guys again. Now, at 1, we have a completely constant lens. And so let's go to 2, because that's what we're going for. We're going from 0 to 2. So let's go to, let's start actually with 0 over r. And let's go down. So this one's not going to give anything because the error of 0 over r is undefined. But if we do 0.1 over r, give it a second, you'll see, yes, we have an incredibly big change in refractive index, right, as it goes along. And 2 over r, we now have an incredibly small change in refractive index as it goes along. So what we're doing, see now the refractive index tapers off much more. What we're doing here is we're changing the internal properties such that the refractive index on the inside goes from what was before a massively changing refractive index to something that is now basically not varying over that time. And that's why the simulation looks so incredibly cool, because the idea is that we took the function and we just stretched it out, and now we're set. Anyway, I'm sorry, I just find this really cool. It's one of those simulations that you see it and you're like, I don't understand what's happening, and then you're like, oh, okay, I kind of get it. Now how am I going to how do I describe this to people? No idea. No idea whatsoever, but it's still pretty cool. Hey, the Matt Dave, thanks for coming in. So, why is it advertising for Pi Day? Isn't that like half a year away? Maybe. Let me see. Okay, so now let's go ahead and modify some functions up a little bit. So what I want to do is, let me go into clear geometrical.h, and let's modify a couple things. First, we want to modify the make sphere command in here. And what we want to do is we have double radius constant t function, but I also want to read in here the index parameter. So let me see. Let me go to where we have it up here. Index parameter comes before function. And so we'll say the following. We automatically set it to 1.0. However, let me think. If we give it a constant index. Yeah, so let's just do, let's read in the index parameter. So we'll say, what is it, double IP. Why not? And then we're going to go down here and say index parameter of IP. Oh. What? 1 second, let me think. Origin, radius, return sphere t. Oh, maybe we can just do IP? Oh, I see. We have to modify it up there. Good. That's what we need to do then. So, double radius constant t. Let's go over here and add in a double IP. Right here. Double IP. And then we're going to go down here and we're going to write in index parameter of IP. Good. So this one should work. Let's remove a space over here. Now, when we call it over here, what I want to do is the following: error index constant equals 1.4. Here, lens.index parameter here. Let's go up here and change this to a 0.5. Okay. Okay, so now what I want to do is when we go down to the bottom here, to the constant index, I actually don't care about reading an index here. So let me comment a couple guys out. This guy, and this guy, and then return index lens.index parameter. Can friction exist between two magnetic fields? I mean, kind of, right? I mean, you have, I was thinking like an eddy current or something like that, but can it exist between the two fields? I mean, the fields are just going to add together, right? So it doesn't really... Yeah, I mean, they're just going to add together, basically, I think, unless I'm thinking of things completely incorrectly. But now, you could go down to a very small level, like the level of atoms and things like that. And in that case, the magnetic spin opposing fields, well, like even opposing fields, right? So if you have one magnetic field going this way, another one going this way, they're just going to add together, right? Just to make zero. So it's not really friction. Okay, so I don't think this is going to work. I think I'm screwing something up here. Lens vector P, constant, let me see, operator, constant sphere, vector position. Oh, let's just see what happens. So let me right quit, and let's make this. Okay, obviously it gave us some problems. Geometrical.h116, let's go over here. Yeah, so that's actually what they do. I think they create like, so the thing with the train, right, is they have, and again, this is, I don't know much about this, but they have basically a metal something that goes along. I don't have a lens. Oh, yeah, let's go into geometrical.cpp. Oh, wait, geometrical.h116. H116. Here we are. Return lens, constant index. Oh, what? How do I return? What? Wait, that doesn't make any sense. Because we could return it down here. Double operator R. Oh, that's why. Lens. Right quit. Now we need to go into geometrical.cpp and remove the 1.4 here. And we're going to check this out in just a bit. So let's go over here. Let's make that. Index parameter. Lens.index parameter. Do you mean index param? Of course I did. Thanks for noticing, man. Man, this is such a nice compiler. It knew what I wanted. So let me do 116. Here we are. And let's do index param. Right, this, make. Okay. So give it a second to do its thing. It's doing exactly what I want. Now let's do the same thing again with geometrical.cpp, except with a constant index. And guys, there's a couple lenses that I want to implement that I might not be able to implement today, so we might have to do it tomorrow. My apologies. So we have constant here. Let's go over here and let's do constant. And one thing that you mentioned a second ago, Zadiston, is that we can do this. Something like that. Let me see if that works. Oh. And let's go down here. Index. And now, I'm sorry I got super distracted. Gothic Death Eater. What you were talking about was the train itself. So, the issue is that you have some giant hulking metal object. Yeah, I think I fixed that. Going along another metal object. So, what you're doing is you have a force that is being you have a force that's acting on the objects themselves, but the magnetic field is pretty standard, right? So the field itself is not you don't have any friction between the field, you have a friction between the two objects, if that makes sense. And this is of course my own understanding. If you have a better explanation of this kind of stuff, let me know. I don't do E&M stuff so much anymore. I used to do it a lot with plasma stuff, but even then magnetism was not something I hit a lot. Okay, so let's go ahead and look at this one. It should be the same as before, Mirage. Yep, exactly the same as before. Now, let's go ahead and do the constant index guy. Let's go ahead and write this, go over here and make that. See what happens. What's the worst that could happen? I don't know. Okay. Give it a second to do its thing. And this, I think, is the best way to do it. I like it this way. This way we read in the index parameter. We can modify the system based on the index parameter. All that kind of stuff. Now, the problem is, I have no way I have no idea how I want to visualize the equation that we're working with for the error function guy. So let's scroll down. Good. This is what I want to see. Now, for the invisible lens, which is going to take a little bit of time. So let's go into right quit, geometrical.h, and let's do it. So, inverse error function. Here we are. Now we do struct for the invisible lens. I don't know what I was trying to spell there. Maybe I was writing it in Pig Latin? Ensley? I don't know. I don't know what I was trying to do there. So we're going to say struct invisible lens index. Let's do that one. Okay. So we're going to have to return a double, as always. And let me just go ahead and move over here. Drop that down in size. Go over here. Because it's written. And Gastorn, in general, writes cleaner code than I do. So let's do double operator. Operator. I'm not typing today. We'll do sphere. Invisible index. Oh. Okay, that's fine. Good. Invisible index. And then we're going to say lens. And we need vector P. Okay. So this is calling the position and everything else. So we're going to say double index. Oh, did you? Double cutoff. Equals 0.001. Good. Did I forget the Oh. Okay, yeah, let's do that. Thanks. Good. Okay, so what do I want to do next? Well, we're just going to do it. So we're going to say double A is going to be equal to lens.radius. Oh, yeah, I remember why I did this. Lens.radius. And then we're going to say double R is going to be equal to distance. And the other const? Where's the... Oh, yeah, you're right. Sorry about that. Okay, so we're going to say distance of lens.origin. Then P. Good, add in a semicolon there. Now we're going to say if f abs Okay, of r is greater than the cutoff, we are going to do the following. And honestly, guys, I'm going to cheat. I'm totally cheating. Let's go over here. That was weird. 7? 8? What? Oh, huh. Okay. The fabs is unnecessary. Wait, why did you say it's unnecessary? Sorry about that. I must have missed it when you said it before, or else I just forgot, which is my bad. Sorry about that. Let's go here, copy that. Is that right? No, it's not. Okay. The distance of a vector can never be negative. If oh. Oh yeah, you're right. You're right. So let's go down here. And let's see, we return index inside here. So we're going to return index. Good. Let's go here. We can remove it. That's fine. Right, this, go over here, pop that there, and let's go ahead and clear. Make, just to make sure it makes. Error expected semicolon. Of course you did, because this is a struct. Here we are. Write that, go over here, and let's make that. Good. Okay. This seems to be doing something okay. Yeah, that's okay. So now let's go ahead and check out the invisible index. Right and quit. Let's go into geometrical.cpp. And let's do it. Invisible index. Let's go. Super excited. Write this, go over here, make it. Okay, so the index parameter has nothing to do with this particular simulation. Oh wow, this is taking a while. Why is it taking so long? Let's not worry. Let's not do a propagate sweep with this one, because it's not going to propagate mod. It's not going to do anything. So let's go ahead and this, just do propagate. Write this, go over here, and let's make that. Give it a second to make. It's going to take a little bit of time. I will admit that, but it should be okay. Also, the index for this one goes through the roof at 44,000 or 4480.7, so it's quite high. Now let's go to the last mirage. Okay, and let's see what happens. Here we have the invisible lens being created. Okay, now I want to very carefully explain this. This top ray, watch the very top ray during the simulation. That is the speed of light. Now, the speed of light has now gone off the screen. We'll say it goes off the screen here at frame 111. Okay, now let's watch the rest of the simulation. The rest of the simulation hits the edge of the screen. Oh, it actually doesn't hit the edge of the screen. Yeah, we have to let it actually run a little bit longer. So the point is, the speed of light outside of this lens is moving incredibly fast. Meanwhile, the speed of light inside of the lens is moving incredibly slowly. Well, incredibly. There's a time delay, basically. So you might be asking, what is the point in the lens? And that's a very good question. I'm going to open up my blinds. Oh, it's a beautiful day outside. Sun's shining. It's a little bit hazy, but that's okay. It's a good day. Okay, so now we have to implement a whole bunch of other functions. And I say have to. Now we have the opportunity to implement a whole bunch of other functions. And I want to try something a little bit weird. Something that we hadn't tried before. I want to do a piecemeal... Does it still work if the light enters at an angle? Yeah, it totally works at any angle, right? Because the sphere is symmetric. So we can rotate that sphere no matter what. And if we rotate the sphere anywhere, like any way, right? Basically the light is entering at any angle. You see what I'm saying? Like, if we send a light right here and we send a light right here, you know, it doesn't matter. You know, because in essence, we could just rotate the circle so that they're at any angle, right? Does that make sense? Like, because of symmetry, it should work. Yeah. I mean, yeah, you're right. Okay. Man, this one just looks cool, though. I mean, come on. You're good, Gustorn. No, it's not a stupid question. Okay, there are stupid questions, but that was not one of them. I know, like, your teacher in high school always used to say, there's no such thing as stupid questions. And you're like, well, there is such a thing as a stupid question. If the answer is already provided for you, or you already know the answer, then it's a stupid question. We were taking AP chemistry in high school. The idea is AP classes are like college classes that you take in high school. And honestly, I couldn't imagine not taking those classes. Like if I was in honors classes, I don't know. It just, anyway, that's beside the point. Anyway, I was taking an AP chemistry class. And my teacher went on this whole thing about how there were no such thing as stupid questions. And immediately after, this guy raises his hand and he asks, you know, why are those elements blue on the periodic table? Which was fine, except for the fact that there was a key right there that clearly said why they were blue on the periodic table. And not only that, he had just said that the color indicates the state of matter that they're at room temperature. And so he had just stated that. So he'd already given the answer. The answer was already provided on the wall, which is where the periodic table was. And he still asked the question. And so in that case, I'm kind of like, okay, that question maybe didn't help anyone understand anything better. So that said, it was kind of funny because I think he meant it ironically, I guess, because obviously, I don't know. Anyway, the point is, those are the only types of questions that I think are stupid. The ones that you already know the answer to and you're only asking because you want to draw something out of someone or something like that. So if you're in a debate and you ask a question where someone has to answer a certain way, well, I don't know, that's a stupid question because you're only asking to get information you already know. But here, sorry about going on a tangent about that, guys. Anyway, let's move on to the next one. Before implementing other lenses, actually, let me delete this guy over here. Let's go ahead and clear. Now, what do I want to do? We've got plenty of time here, guys. Tomorrow, what I want to do is re-implement a whole bunch of the different lenses and stuff like that. Plenty of time to do that tomorrow. Today, I want to try implementing a piecemeal lens. So let me go ahead and do, let's see, vi geometrical.cpp. This, in essence, let me think. This is going to be, why am I in geometrical.cpp? I want a geometrical.h. This is going to be a pretty easy lens to make, I think. But it's a good test, just to make sure that all of the different elements of this particular code is working. So struct for error function, struct for invisible lens. So I'm going to create a new struct in here that I'm going to call struct for piecemeal lens. How do you spell piecemeal? Piecemeal. Good. So we're going to say struct piecemeal index. Okay, so this is going to be obviously a super simple index. Here's what we're going to do. We're going to say the following. Obviously add a semicolon because I keep forgetting. And we're going to say double operator operator, and we're going to read in constant sphere of, and we're going to read piecemeal index. Now, do we actually need the sphere itself, the lens? I will say yes. Then we're going to say vector p. Then we say constant. Sorry guys, I didn't mean to stop the chat. Feel free to say anything you want. I apologize. Okay, so let's do, what do I want to do? I want to say, at the end we're going to have to return index. I forgot an ampersand. Thank you. Add an ampersand in here. By the way, guys, I just wanted to point something out real quick before continuing. I love the fact that you guys are watching and you guys are like critiquing the code as we go along. Like that is seriously the most helpful thing and probably the coolest thing about live coding in a way. The fact that you know, I think it's really good for me as a streamer because I'm learning a lot of stuff. And I think it's good for you guys because you're able to see other people code and critique the code and stuff like that. And I think overall, this is a fantastic environment to learn programming in. You know what I mean? And I just wanted to point that out, that this is kind of special in a way. This stream is actually super special. And it's the reason I keep doing it every morning, or pretty much every morning, except for every few days, is kind of because of that, you know? Like, it helps me. I feel like you guys are getting something out of it. It's just a nice thing to do, and I feel, I don't know, I kind of just like it. It's fun. And I realized, sure, you guys already knew that maybe, but I don't know. I was realizing how cool it is just yesterday. I was sitting there and thinking to myself, man, if only there was a way for me to, you know, code and have a whole bunch of people look and critique the code as I'm doing it. And I was like, actually, I do that every morning from 5 to 7 o'clock. And I just thought it was cool. I don't know, maybe you guys think something similar. Okay, so what I want to do here, basically what I want to do is define a couple of different parameters. So we're going to have basically a set of, how do I put this, radii that we're going to turn on and off, if that makes sense. So here's what I'm going to say. I'm going to say std vector of, let's call them doubles. Okay. Now, what I'm going to do is I'm going to just give these guys a whole bunch of random of positions. Now, I always forget how to initialize a vector because I've done it a few times and I keep forgetting. So what I want to do is this, and you guys can tell me how I'm doing it incorrectly. So I want to do, let's see. We have, what am I looking for? We have the lens itself, which gives us a radius. And what I want to do is I want to go through, wait a minute. Yeah, so what I want to do is this. I need a variable name. Oh. I already broke it. So we're going to say radii. Radii? And we're going to say 0.1, 0. You know what? Let's not do this in a vector. Let's do it another way. I was gonna try to do this, but no, I think there's a better way to do this. So let's say for int I equals 0. Then we're gonna say I less than, we'll just say 10 for now. Then we're gonna say plus I. And then what we're gonna say is the following. Okay, so what we need to do then is basically create a whole bunch of if statements, so to speak. So we're going to say if, how do I put this? If, we'll say distance of lens.origin and the position vector is less than, and we're going to say lens.radius times I. Let's say double I divided by 10, times 0.1. We will say, okay, so it has to be one at the very edge, so that we have light going in. So let's say it's going to be equal to I'm not sure how to do this one actually, guys. I'm trying to figure it out and I'm not really doing a good job. So let me just do this. I just want to draw something that looks clear as to what we're doing. So let's do 5 and then we're going to do this. We're going to say 1 minus I times 0.2. Index equals that. Now let me go up here and let me just say index, double index. Okay, so basically the idea is light comes in, it has an index of 1. Then, let me see. If it's less than, yeah, something like this. Let's just see what happens if I run it. I'm kind of at a loss here. So let's go here. Let me change this to piecemeal index. And let's see what happens. Index. Oh. Let's write that. Let's go over here and let's make it. It's probably going to break. Oh, maybe it'll work. We'll see. Max index is 0.2. So it clearly broke. Let's see what happens if we run the last mirage. Okay, so there's our lens. Yeah, that's not right. Yeah, that wasn't exactly what I wanted. It's kind of weird though. Okay, so let me see. What was I trying to go for? Let me go into VI geometrical.h. Let's go down to the lens one more time. That wasn't at all what I wanted. What I wanted was, let me see. I wanted something that clearly had a different index. Let's just do it this way then. We're gonna say double index, and we're gonna say DD, DD, 1, 2, 3, 4, 1, 2, 3, 4. Why not floor, lens origin P, divided by lens start radius times D, where n is the number of steps and d is the difference between each step. Floor of distance equals a distance of lens origin. Yeah, let's try that one. So it's floor distance index equals floor of distance of lens dot origin position divided by lens dot radius times n, which we'll say is for now 5, and then what we say, so let's see, what is this doing? Lens dot origin P, that's going to be a length. So the floor here. Okay, so then we're dividing it by the number of steps, and then what do? We say index is going to be equal to, oh, I see, so we just created a fraction, so then let's just multiply this by 5. Wait, 1 second, that doesn't make any sense. 5 can't be the distance between each step. Let me think. So if it's 1.0, then in the end this should be a 1.0, right? So let me think. It should be that if the distance is at r, we have to have an index of 1. So let me think, how are we going to do that? If the difference is at r, it has to have an index of 1. Times 0.1 plus 1.2. Oh, I see what you're trying to do. Yeah, so let me see. So we have lens, so if the distance is, see, divide by lens dot radius times 0.5. Let me go down here and let's add in some parentheses there. So now what we're doing is we're splitting it up. Let me think. Divide by lens dot radius. Screw it. For now, let me just do this. If, I just want to check something real quick. If, wait. Let me check this again. Yeah, we can try that then. Let's try times n times n, which is going to be 5, times 0.1 plus, let's do plus 1 actually. Okay, so let's write and quit, and let's make that, and let's see what happens. Values computed but not used. Oh, oopsie. Let me go to geometrical.h, and let's do piecemeal. Okay, let's go here, and let's do index equals that. Right quit, and let's make that. Okay, now let's see what happens. I think it is a little bit off. Max index is 1.4 though. That's about right. So let me do the last mirage. Oh, okay, this is what I wanted to see. Look at that. So it looks like it's 1.4 at the start. Okay, well. yeah, 1 second. Okay, well that looks kind of weird, but it's kind of what we expected, right? So let's go into geometrical H one more time. And let's go down to piecemeal. If I can spell peace. Yeah. So let me see, here's piecemeal. So let's do 1.5 minus that. So let's do 1.5 minus, right quit, and let's make that. So now I guess it starts at 1.5. No, it ends at 1.5 in the center. Okay, let's see what happens. So let's do mirage temp image. Yeah, okay, so now it's highest in the center. Okay, so that's about right. Now you might be thinking, this is kind of a waste of time. Kind of. Now what I want to do is this. Okay. Now how I'm going to do this. I don't know, I have to think about this one a little bit more. But there's definitely something to do here. I wanted to try concentric circles with the index, but that's okay. Let's just kind of work on other ones for now. So let me do geometrical.h. Let's go down to inverse. There should be an inverse somewhere. Here we are. Struct for invisible lens. Now let me just do struct for index, or for inverse. Let's go down here and we're going to say struct for inverse 1 over r. And we're going to say struct inverse index. And what is this going to be? It will be the following. So we're going to have to go down here, add in a semicolon, and we're going to say double operator of the following. So we're going to say constant sphere of inverse index ampersand lens. Do we need that? Yes, we do need that. Definitely need that. Then we're going to say vector position. Okay, then we're going to say const of the following. We say double index, and we're going to say index. Why don't we just do it this way? Return. What do we want to return? We want to return 1 second. 1 over r. So it'll be 1 divided by. How about we do this? We say lens dot index parameter divided by, and what do we want? We want r. So this is going to be distance of between lens dot origin and position divided by lens dot radius. I think that's right. So we have index parameter as the constant out front, and then we divide it by lens dot origin p. So that's going to be how far away we are from the center, and then lens dot radius should. Okay, so I think this is right. Let's go over here and let's change this to inverse index. And let's go over here and right quit, make. Now, one thing to point out is that the value, max index is infinite. Oh, I know, of course the max value is infinite. That was me being stupid. Okay, but we'll take a look at what this does. So let's do mirage image, and here we have it in the center, and yes, that is about what I expected. Okay, let's try this again. Except in this case, let's change it so that this is a 1.0. And let's go into the geometrical.h. Where are we? Geometrical.h. Actually, you know what? Let's just make it. So go over here, write this, go over here, and let's make it. Max index is infinite. That's fine. Give it a second to run. And I think the light just constantly, it's all sucked towards the center, I think. Mirage image, scroll down. Yeah, so here we are, it's all sucked in the center. In fact, the cool thing about this one, if I remember correctly, is that we could continually zoom in here, but because of the way we're doing the resolution here, it's not quite going to work out. So, that's our 1/r guy. I don't know if you guys remember or not, but it just continually goes in further and further. Creates like some sort of crazy fractal pattern on the inside. Yep, so that's 1/r. I'm happy with that one. Okay, now let me think. I also have not tried just standard R. So let me see what happens if we just do the following. Let me do, and this isn't quite right, but let me just try it. Geometrical.h. Let me go down to inverse, and we should have another one down here. Yep. Let me just modify this guy. So instead of being divided by, we do a multiplication. Let me go ahead and right quit, make. Now, of course, this is not an inverse. I totally get that. I just wanted to see what would happen. So now let's do geometrical.h. Oh, sorry. Now let's do the last mirage. And let's scroll down. Oh, yeah, of course. I remember this one now. Yep. Because it's 0 in the center, eventually they have to fall away. Yep. Yep. Okay, good. So I'm going to do that one too. So let me go to geometrical H. Let's go inverse. There we are. Inverse. Next one. Index. Let's do 1/r again. And now let's do R index. So we're going to do another struct for R index, which is going to be literally the same thing. So I'm going to copy this. Struct for R, I guess. I can't think of a good way to put this. So we're just going to say R index. And go down here and say R index. Okay, so now we're going to say index parameter times this. And let's test it out. So let's see, radius, inverse index, R index over here. Right quit, and let's make it. Okay, so this one should do exactly what it did before. Okay, so now it's just a matter of basically incorporating a whole bunch of different functions into this simulation. And we've got a lot left to, or we got a lot that we could do here. But we've done it kind of before. So I'm gonna leave it up to you guys. We have, let's see, 10 minutes left for today, 15 minutes, something like that. And what we can do is we can just kind of go through and continually change the function that we're working on and kind of do a whole bunch of interesting things. But another thing we can do is we can kind of call the simulation here and start working on the next one in the next few days. I need a few days to prepare. I'm honestly not prepared at all for the next simulation. So we might need to take another day just kind of working with different functions. And if you have any ideas of functions that you may want to try, let me know. Because this is totally the time just to try to test around and see what happens if we change, add different functions of R. There are, of course, a whole bunch of other things to work with. So basically all of the functions that Gustorn has given us before and all the functions that we've done. Yeah. Well, here, let's just go ahead and add all those functions in. So we have a whole bunch of other functions to work with. So let me do geometrical.h, because I remember the Batman function being particularly interesting. So let's go down to the inverse index. There we are. And let me go down here and let's add in another struct for part of the Batman function. Okay, we're going to say struct Batman index. And let's just go ahead and add a function in here. Let's go here. We're going to say double operator. And we'll say constant sphere of Batman index. Add an ampersand and say lens. Then we say vector p. Constant. Okay, now we go down here. And let's do it. So it should be available on GitHub. Should have a gist about it. Maybe it's in Let me go to my profile or something. No, I have to find it. So let me go to github.com. Actually, you guys can find it too. Here's my stream. Go to info, scroll down to the very bottom. And let's go to github.com right here. Okay, so now what we're going to do is go to Simuleos and should be issues. Few refraction index functions. And this one. That's the one we want. So let's go down here and let's put it in. Paste it. Okay. So index equals this. Good. Should be okay. So let's add another couple guys here. And over here. Good. So that one doesn't quite fit. So let's go ahead and return index. And let's see. We're using this thing called diff. Let me think. So let's go ahead and define diff. So we're going to say here, double. That wasn't how you spell double. That's okay. And we're going to say double diff is going to be equal to, let me think, distance of what do we want here? Let's say lens.origin vector position p. So it's going to be diff. What else do we have here? Diff is that. And then we have to divide it by lens.radius. Okay. Write this. And let's go over here and change this to Batman index. Write this, go over here, right quit, make. Of course, forgot something. So let's go here. Let's go to 182. The one line I actually had to write. I forget the semicolon in. Right quit, make. Okay, give it a second to do its thing. Max index is 3. That's about right. Okay, and we'll take a look at this one as soon as it's up, which is right now. So let's do, where is it? Mirage temp. Here's the light going in. That seems to be different than what I remember it to be. I remember it looking differently. Huh. Didn't it look different, or am I thinking of a different function? I might be thinking of a different function. Because this one looks familiar to me. I just thought it wasn't the one I was plotting. Okay, so let's go ahead and close this. Let's try another one. Geometrical.h. And let's go down to, I guess Batman, because it's the last one we wrote. Okay, now let's go down here. And let's just add another function in here. So, let's see, square root, cube root, those are basically going to do the same thing as expected. I don't remember this one though. So let's say the following. We're going to say struct for, let's say, so exponential decay of r. Let me think, what's that one going to do? So at the very center, we're going to have a very high index. And okay, so it's kind of similar to what we have for. For a function, try 2 times minus slope. What do you mean for minus slope? Oh, okay. So let's do this then. We're going to say struct for 1.0 divided by 1.0 exponential plus 0.5. How about we say... Oh, let's just say struct for function. And we're just going to call it struct function index. Okay. Oh, sigmoid. Oh, it is. Okay, good. Signum. Sine. Wait. Signum is different. So no, sigmoid. Let's say sigmoid. Okay, there we go. Sigmoid index. Okay, then we're going to say D, go down to the end here, and let's do it. So sigmoid function index. So let's go here, and let's say double operator, and we need to read in constant sphere, sigmoid index, ampersand. It's okay. So let's see. Lens And we should need the lens, I think. Yeah, we should totally need the lens. And then vector position. Now we do constant. Open it up. Next line. And let's do the following. We're going to say double R is going to be equal to, let me think. It should be the same thing as we had before. This guy up here. Okay, now we're going to say index is going to be equal to 1.0 divided by 1.0 plus the exponential of the lens.index parameter times R. And I forgot a minus sign. So let's add a minus sign in here. Okay, now we say right and we return index. Okay, right quit. Let's make that just to see what happens. Index is not declared in the scope, fair enough. So let's go down to sigmoid, or sigmoid, yeah. There we are, and let's do double index. Good, let's right and quit. Make it. And then we're gonna try a propagate mod. Okay, so propagate mod's next. Write this. Go over here, let's take a look at what it looks like. Mirage. Oh, I forgot to change it. So let's go to signum index. Sigmoid. Sorry. So sigmoid. Write this, go over here, make that. Give it a second to do its thing. And it should go all the way up to 2. So let's see what happens. Good. So I think after this, guys, we'll go ahead and call it for today. I think we got a lot done. I'm pretty happy with how far we got. But this will take about a minute or two to run, and then we're at a position where we, it's almost 7 o'clock, and I think that's about right. We'll just see what happens. So let me think. Should we do another day of this? That's the question. If you guys want to, we can do one more day of this. Otherwise, we'll take a day off tomorrow while I try to figure out what to do next. Again, I have basically nothing prepared, which is more or less my own fault. I just haven't been able to get stuff done. So we're going to have to take a day off before the next simulation no matter what. And in fact, we might have to take more than a single day off. I mean, I'm significantly behind in understanding what to do, like, for the next simulation and stuff. So we're kind of at a standing point here. So if you want to, we can do this one more day, and we just kind of put a whole bunch of functions into the system and stuff like that. Or we can kind of call this simulation here, not do it tomorrow, and I can spend tomorrow kind of reading up and trying to figure out what to do next. Okay, so this guy, oh, actually it is quite interesting. I mean, look at this. So the idea is at 0, even at 0, what's interesting is we have light going into the system. So here, it's at basically 0, and we still have light going into the system. That's not expected. And then as we go down, it doesn't actually change that much, which is kind of interesting in its own right, right? I mean, let me see. So what happens if we plug in 0 to this guy? The exponent, oh, okay. So that obviously makes sense, right? Because if we have the exponent of negative slope, and slope is equal to 0, then the exponential of 0 is going to be... Okay, so yeah, that makes sense, I guess. Okay, so then it zooms down. Yeah. Okay, so it's up to you guys. Let me know what you guys think. We can continue working on this tomorrow, or we can spend some time, or I can take some time working on the next simulation after this one. Totally up to you guys. Again, today was kind of, it was a good day. We got a lot done. Pretty excited about that. I don't think there are too many new people to come to the channel, but that's okay, you know? The way I see it is discoverability on Twitch right now for programmers is negligible, right? So it's not particularly easy to work with. But the structs are replacements for lambda functions. I hope I don't bring up a discussion you had earlier. No, the structs, well, okay, wait, let me think. You could kind of argue that the structs are, in a way, a function that we're implementing for the inside of the index, for the inside of the lens. However, I'd argue they're not really related to lambda functions. What we're doing here is we are reading in a template. Oh, okay, maybe they are kind of similar. I see what you're saying. Yeah, in a way, yeah. It's just because this is a complicated system, as Gustrun said, we have to kind of do it another way. And honestly, the template solution I think is quite nice. It works out quite well. Okay, so again, guys, let me know what you think. You can send me a message here or there if you want. And right now we have a whole bunch of different functions implemented. So let me go to geometrical.h. Let's scroll down and let's just take a look. We have the invisible index, the inverse error function, a whole bunch of things implemented today. So let's go ahead and right quit. Let's go over here, right quit. Let me do a git status dot, and let's see what we have. Hey, John Hamlink. So we have, let's see, makefile, geometrical.cpp, and geometrical.h. The only ones that I think were really updated were geometrical.cpp and geometrical.h. Let me take a look at the makefile. Git diff makefile. Yeah, so it looks like let me do this then. So let me go into the let's actually commit the makefile this time then. I think it's probably best to do that. Yeah, so let's commit the makefile. And actually I just realized something. Let me go into the makefile. I put in the wrong comment here. Not that it will do anything, but that was definitely the wrong comment type. Sorry about that, guys. Okay, so I'm just gonna go ahead and commit the makefile and a whole bunch of other things to GitHub. So we'll commit the makefile, geometrical.cpp, and geometrical.h. So let's do git commit makefile, geometrical.cpp, and geometrical.h. Now I'm not going to commit geometrical.gp because there were not very many changes to that one. Good. Git commit makefile, geometrical.cpp, geometrical.make, geometrical.h. That's what I wanted. Okay, so we're going to say adding in many possible index functions. More to come. Good. Right quit. Then we do git. Rewrite of geometrical optics makefile. Oh, okay, I see. 123 lines inserted, 46 deletions. Seems fine. Git push origin master. Good. So now it should be available on github.com. Feel free to take a look at that if you like. We obviously have more functions to add, and if you have any functions you want to add, just send me a pull request or something like that, and I can totally add them in as soon as I see them. Outside of that, we may or may not take tomorrow to basically implement a whole bunch of different functions and just play around with the code, getting a whole bunch of animations and stuff up for the YouTube video I'll be putting out this weekend on this material, but we'll see how that goes. Outside of that, if you guys have ideas for the next simulation you may want to run, we have, wait, what am I saying? Outside of that, if you have anything further that you want me to do, just let me know. Send me a link or send me a message somewhere on Twitter or here on Twitch or something like that. I'll do my best to respond as soon as I see it. John Hamlink, I'm going to try to have my streams from 2 o'clock p.m. to 4 o'clock p.m. CST, which is about 5 o'clock a.m. to 7 o'clock a.m. my time. Yeah, it's currently 7:02 in the morning my time. So I am actually at the end of stream today. Sorry that you came in at the very end. But again, I'll be live tomorrow at 5 o'clock a.m. my time. So, well, wait. Actually, you may have come in at the wrong time because I might not be live tomorrow either. It kind of depends on how things work. So if I think there is merit to doing more coding tomorrow and adding in some functions, I'll totally come tomorrow. But if I don't think there's any merit to it, I might skip tomorrow and I might spend the time instead learning about the next simulation, which could be something about mapping. I'm not really sure. Lots of stuff to work on. But typically, I'm live 5 to 7 o'clock a.m. Japanese Standard Time every day. So that's about that. Anyway, guys, thanks so much for coming in. Have a great... yeah, I think we can too. We'll see what happens. So anyway, guys, John Hamlink, I actually used to get up even earlier for morning swim practice back in high school. And then throughout college, I kind of like stopped getting up early and I just felt like crap. So I think getting up early is actually the optimal thing for me to do. Yeah, so if you guys have ideas for cool functions to work with, let me know. I'll try to think of a couple ideas too. Honestly, I think it's good to have a wrap-up day. Just a day to kind of like, because we've been working on the simulation for the past couple days, actually past week. More than the past week. We've been working on this for the past 2 weeks. And I have to apologize for taking so long. Somehow, it always takes longer than expected. But we have some really cool visualizations to work with, and I'm pretty proud of that. But we also spent time like 6 months ago working on this too, right? So in the end, we've got a lot of stuff to cover. So I think it's good to do a final wrap-up day of the Geometrical Optics. Pretty excited to see how far we get there. We'll probably be live tomorrow. I'll let you know if we're not. Again, it'll be from 5 to 7 o'clock a.m. my time, so 2 hours before this time, whatever time it is your time. And then I'll take some time to try to figure out what it is I want to do for the next simulation. I have a couple of ideas, but I don't know if I can learn enough about them before the next simulation. So we'll see how that goes. Anyway, guys, thanks so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos, where we either continue working on this code, or we move on to the next code, depending on how things go. And I'll let you know in the stream title and stuff like that. You'll know if I'm not streaming tomorrow how things go. Anyway, thanks again for coming in, guys, and I'll see you next time. Bye, guys.